Hi there, you are welcome to this channel. If you are new, subscribe to the channel and get more videos. So today we'll be looking at IP addressing V4, that is the part 1, and this falls under data communication and computer networking. But first of all, before we start, I would want us to explain or know what IP address means. So when we say IP address, an IP address is a unique number that is assigned to a device or a network. So it is a unique number that is assigned. So let's write it down. So an IP address is a unique number. So it's a unique number that is assigned to a device or network. This is the definition of IP address. We can add more. It is used to identify and locate devices on the internet or a local network. So it is used to identify and locate a device on the internet. So on the internet or local network. So this is the definition of an IP address. Now let's give examples of an IP address. So you can write this down. Don't forget examples of an IP address. We have 192, we have 168, and we have 1, we have 1. This example. Then number 2, we have 8, 8, 8, 8. So this an example of an IP address. Now let's move on. So IP addressing. So look at this. You can take a screenshot of it and copy it. So let's move on. I want us to move on quick. So now IP addressing. Here we have the heart of TCP or IP is Internet Protocol, addressing and routing. So an IP address is a numeric identifier assigned to each device on an IP network. So that is what we said earlier. It is a numeric or a unique number. So here we have that is a numeric identifier assigned to each device on an IP network. So the IP address provides the location of the device on a network. So normally, sometimes this is how the IP address looks like. As I said earlier, we give examples. So 1, 1. Now, this IP address provides the location of the device. So let's say this IP address, for instance, let me clean this now. Sorry. So let's say HTTPS, let's say UPSA dot edu dot gh. Now, this is what we search. This is what we search. But before everything can, run or process on a computer or on your laptop or on any device, This is what the device understands. So let's say this is the IP address of this. So this is the IP address of this. For instance, we are just giving an example. So upsa.edu.gh. So this is the IP address of it. Now, the IP address provides the location of the device on the network. So it provides the location of the device on the network. So this is it. Now let's move on. And IP addresses are logical addresses implemented in software, unlike MAC addresses. So an IP, we will explain what MAC address means. So an IP address. So here we have IP addresses are represented as binary numbers in four sets of 8 bits called 8 bits each, called an octet. In IP protocol version, in Internet Protocol version 4. So when you write something like this is the meaning: Internet Protocol version 4. So this is the meaning of the IPv4. Now let's move on. Let's move on. Now, so we have IPv4 addresses are logical. So let's write it. So IPv4, sorry for my vin, I don't. Okay, so IPv4 addresses are logical. So 32 bits, 32 bits. So that is into bracket 4 bytes. So 32 bit 4 bytes addresses. Whereas, don't worry, I'll explain them. Whereas IP version 6, so IP version 6 addresses are logical. So that is 128 bits addresses. Now let's take this. Now we have 192.168.1 and 56. So how do we convert this into binaries? So let's solve for this IP address. Let's try converting this IP address to binary. So we are converting this into binary, that is base 2. So base 2. We are converting this to base 2. You can do this on your calculator, very simple. So on your calculator here, you have the mode setup. So you click on the mode setup, then you see base n, that is option 4, number 4. So you click on number 4. When you click on number 4, you are going to see decimal, like base 10. So this is our IP address. This is the IP address, and we have to convert this to binary or base 2. So how do we do that? So you can do this on your calculator. You go to mode setup, then you click on base option 4, that's base n. So here on your calculator, where the x exponent 2 is, we have the dec, hex, bin, and oct. So once you go there, automatically a double code deck, like deck. So for there, you click 192 is equal to, you are still going to get the 192. Then after that, you press on the bin. So you get something like this, something like this. That was just by the way. So now let's move on. Let's solve it manually. So we have 192 here. This is our remainder, and this is the divider. So 2 will go into 192, 90. So 192 divided by 2, we have 96, remainder 0. So 2 will go into 96 divided by 2, 48. So 48, remainder 0. So 2 will go into 48, 24, remainder 0. So 2 will go into 24, 12, remainder 0. 2 will go into 12, 6, remainder 0. 2 will go into 6, 3, remainder 0. So 2 will go into 3, 1, remainder 1. So 2 will go into 1, 0, remainder 1. So after this, you read or you count from the bottom to the top. So in all, we are going to get 1, 1, 0, 0, 0, 0, 0, 0. This is what you are going to, so 6 zeros. So this is for the 192. So the 192, we had 1, 1, 0, 0, 0, 0, 0, 0. Now let's move to 68. 168, sorry. So as the same approach, either on a calculator or manually like this. So let's do it. Let's show working here. We have our remainder and our divider here. So 168 divided by 2, we have what? 84, remainder 0. So 84 divided by 2, we have 42. So 42, 0. So 2, no, 2 divided by 84 will give you 42. So 2 divided by 42 will give you 21. So 21, remainder is 0. So 2 will go into 21, 10, then remainder 1. So 2 will go into 10, 5, and a 0. 2 will go into 5, 2, remainder 1. 2 will go into 2, 1, remainder 0. 2 will go into 1, 0, remainder 1. So you read this upwards. So you are going to get 1, 0, 1, 0. So 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 0, 0. So this is what we got. So for 168, we have 1, 0, 1, 0, 1, 1, 1, 0, 0, 0. Now for the 1, it's still 1. Okay, so let's convert the 1 also. So let's see how it works. So we have 1, we have the remainder. So 2. 2 will go into 1, 0, remainder 1. So it's still 1. Still 1. Now let's move to 56. So let me do it well. So it was 1, 0, 1, 0, 1, 0, 0, 0. And this one was also 1. Now let's move to 56. So 56, remainder, and the divider over here. So 56 divided by 2 is 28, remainder 0. So 2 will go into this 14. 14. So 2 will go into 14, 7. So 7, remainder 0. So 2 will go into 7. 2 will go into 7. 3, remainder 1. 2 will go into 3. 1, remainder 1, remainder 1, and 2 going to 1, 0, remainder 1. So we read it upwards. We had 1, 1, 1, 0, 0, 0. So this is what we had, 1, 1, 1, 0, 0, 0. So now we are supposed to get 8 figures, octets. So how do we do that? Because let's count 1, 2, 3, 4, 5, 6, 7, 8. So this is what? 8. 1, 2, 3, 4, 5, 6, 7, 8. So this is also 8. Now this is 1. This is 6. How do we do that? So this is how we do it. We are going to add zeros in addition to this. In all, we are going to get 8. So here we are going to add 7 zeros. So 1, 2, 3, 4, 5, 6, 7. Then we add 1, making this. Now what about this one? So we are going to add, this is 6. So we are going to add 2 zeros in addition. So 1, 1, then go 0, 0. So 0, 0, 1, 1, 1, 0, 0, 0. So 1, 2, 3, 4, 5, 6, 7, 8. So in all, in binary, for the binary for this IP address is 11000000 dot. We are dealing with IP addresses. So then 10101000. Then we have 000000. Then 1. Then we have 001110000. So this is the this is the binary for this. Ta-da! We are done. So we are done. This is how to convert it to base 2. So in my next video, we are going to convert this to base 10 again. It is a process. Just trust it. You understand. So thank you all for joining today's lesson. I am Henry Enim Entry. See you next time. Bye bye.